Flexible metallic tubing, often referred to as greenfield, serves as a recognized wiring method for various electrical circuits, including branch circuits, feeders, and services. Its primary function, in the context we're discussing, involves its utilization as the equipment grounding conductor. The National Electrical Code, (NEC), provides specific guidelines and limitations regarding the use of flexible metallic tubing, particularly when it is employed as the equipment grounding conductor for a transformer. One crucial aspect to understand is the maximum allowable length of flexible metallic tubing in this application. According to the NEC, the maximum length of flexible metallic tubing is 100 feet when used as the equipment grounding conductor for a transformer. This limitation is put in place to ensure that the grounding path maintains a low impedance, which is essential for proper fault current dissipation and overall electrical safety. When a fault occurs in an electrical system, such as a short circuit or a ground fault, a large amount of current flows through the grounding path. The equipment grounding conductor, in this case, the flexible metallic tubing, provides a low impedance path for this fault current to return to the source, typically the transformer. A low impedance path is crucial for several reasons. Firstly, it allows the fault current to quickly and effectively trip the overcurrent protective device, such as a circuit breaker or a fuse. This rapid tripping action minimizes the duration of the fault, reducing the risk of electrical shock, fire, and equipment damage. Secondly, a low impedance path ensures that the voltage rise in the grounded metal parts of electrical equipment is kept to a minimum during a fault. Excessive voltage rise can create a dangerous situation, increasing the risk of electric shock to anyone who comes into contact with the equipment. The 100-foot limitation on flexible metallic tubing length is designed to help maintain this low impedance. As the length of the conductor increases, so does its impedance. Beyond 100 feet, the impedance of the flexible metallic tubing may become too high to effectively serve as the equipment grounding conductor. It's important to note that this 100-foot limitation applies specifically when flexible metallic tubing is used as the equipment grounding conductor. If flexible metallic tubing is used for other purposes, such as enclosing circuit conductors, different rules and regulations may apply. Furthermore, it's essential to ensure that the flexible metallic tubing is properly installed and terminated. This includes using appropriate connectors and fittings that are listed for use with flexible metallic tubing. Proper installation is crucial for maintaining the integrity of the grounding path and ensuring that the flexible metallic tubing provides a reliable and effective connection. In addition to the 100-foot length limitation, there may be other restrictions or requirements related to the use of flexible metallic tubing in certain applications. For example, some jurisdictions may have local amendments to the NEC that impose stricter limitations or require additional safety measures. It's always a good practice to consult with a qualified electrical inspector or engineer to ensure that your electrical installation complies with all applicable codes and regulations. The NEC provides comprehensive guidelines for electrical installations covering a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment selection. It is essential for electricians, electrical contractors, and anyone involved in electrical work to have a thorough understanding of the NEC. This knowledge is crucial for ensuring the safety and reliability of electrical systems. In summary, the maximum length of flexible metallic tubing, also known as greenfield, is 100 feet when used as the equipment grounding conductor for a transformer. This limitation is in place to maintain a lower impedance grounding path, which is essential for proper fault current dissipation and electrical safety. Always consult with the NEC and local codes to ensure compliance with all applicable regulations. Understanding grounding principles is paramount in electrical work. A proper grounding system provides a safe path for fault currents, minimizing the risk of electrical shock and equipment damage. Grounding involves connecting conductive parts of an electrical system to the earth, providing a reference point for voltage stabilization and fault current dissipation. The equipment grounding conductor plays a crucial role in the system, ensuring that metal enclosures and other non-current carrying conductive parts are effectively grounded. This is where flexible metallic tubing comes into play as a viable option in some situations, with the caveat of the 100-foot length maximum. Grounding systems can be categorized into several types, including solid grounding, impedance grounding, and ungrounded systems. Each type has its own advantages and disadvantages, and the choice of grounding system depends on various factors, such as the type of equipment being used, the operating voltage, and the desired level of protection. Solid grounding involves directly connecting the neutral point of a transformer or generator to the earth. This provides a very low impedance path for fault currents, allowing for rapid tripping of overcurrent protective devices. However, solid grounding can also result in high fault currents, which can cause significant damage to equipment. Impedance grounding involves inserting an impedance, such as a resistor or reactor, between the neutral point and the earth. This limits the magnitude of fault currents, reducing the risk of equipment damage. However, impedance grounding can also slow down the tripping of overcurrent protective devices, which may increase the duration of a fault. Ungrounded systems, as the name suggests, do not have a direct connection between the neutral point and the earth. In an ungrounded system, a single ground fault will not cause a large fault current to flow. However, an ungrounded system can be more susceptible to transient overvoltages, which can damage equipment. Selecting the appropriate grounding system requires careful consideration of various factors. It's important to consult with a qualified electrical engineer to determine the best grounding system for your specific application. Proper installation and maintenance of the grounding system are also crucial for ensuring its effectiveness. Regularly inspect the grounding connections to ensure that they are tight and free from corrosion. Testing the grounding system periodically is also recommended to verify its integrity. Flexible metallic tubing offers flexibility and ease of installation, making it a popular choice for certain applications. However, it's important to be aware of the limitations and restrictions associated with its use, particularly when it comes to grounding. In addition to the length limitation, there are also requirements for the size and type of conductors used in flexible metallic tubing. The conductors must be properly sized to carry the expected current load, and they must be suitable for the environmental conditions in which the tubing is installed. It's also important to ensure that the flexible metallic tubing is adequately supported to prevent it from sagging or becoming damaged. The support should be spaced according to the manufacturer's recommendations and should be securely fastened to the building structure. When installing flexible metallic tubing, avoid sharp bends or kinks, as these can damage the tubing and reduce its current carrying capacity. Use appropriate bending tools to create smooth, gradual bends. Also, be careful not to over-tighten the connectors, as this can damage the tubing or the connector. Always follow the manufacturer's instructions for installation and termination. Flexible metallic tubing is available in various sizes and types, so it's important to choose the appropriate tubing for your specific application. Consider the environmental conditions, the type of conductors being used, and the expected current load when selecting flexible metallic tubing. In addition to its use as an equipment grounding conductor, flexible metallic tubing can also be used to protect conductors from physical damage. It provides a degree of mechanical protection, shielding the conductors from abrasion, impact, and other potential hazards. However, flexible metallic tubing is not suitable for use in all environments. It's not recommended for use in wet or corrosive locations unless it is specifically listed for such applications. In wet locations, use liquid-type flexible metallic tubing or other approved wiring methods. Regular inspections of electrical systems are essential for identifying potential problems and ensuring the safety and reliability of the installation. During inspections, pay close attention to the condition of the wiring, grounding connections, and overcurrent protective devices. Look for signs of damage, corrosion, or overheating. If any problems are found, take immediate action to correct them. This may involve repairing or replacing damaged components, tightening loose connections, or upgrading the wiring system. Preventative maintenance is also crucial for ensuring the long-term reliability of electrical systems. This includes regularly cleaning electrical equipment, lubricating moving parts, and testing the performance of overcurrent protective devices. By implementing a comprehensive maintenance program, you can minimize the risk of electrical failures and extend the lifespan of your electrical equipment. Electrical safety should always be a top priority. Never work on electrical equipment unless you are properly trained and qualified. Always to energize the circuit before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work for you. Remember, electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Understanding these principles and guidelines related to flexible metallic tubing is essential for ensuring electrical safety and compliance with the NEC. Always consult with qualified professionals and adhere to all applicable codes and regulations when working with electrical systems.